Okay, hello everyone. I welcomes to all in our lecture series on special integrals, and we are discussing gamma and beta function. In our last class, we have been discussed some important questions on beta function. We discussed six important questions. Here one, two, three, four, five, and this one six. Six important questions we have been discussed in our last class. These six questions are solved by using definition of beta function. Here I am going to show you this one. This is your definition of beta function and different forms here, different forms or representation of beta function. This one, two, and this one, last one, third one is your trigonometric form of beta function. So the six questions whatever we have been solved in our last class, those six questions are solved by using these three different forms of beta function and definition of beta function. In this class, we are going to discuss some other important questions based upon beta function, which are going to solve by using these two properties of a beta function. Okay, so let us start. Here in our last class we have been solved six questions. Okay, so here this six questions. So next question will be question number 7. Here the question number 7, it is given that we have to prove beta pq equal to p plus q by q into beta p q plus 1. Okay, so let us start to prove. First we have to consider the LHS part, then we are going to consider the RHS part. Consider LHS part. Just before I told that this question is going to be solved by using properties of beta function. So we studied two properties for the beta function. One property belongs to your symmetry property, that is your pq beta equal to qp, and another property, second property what we studied, relation between beta and gamma, that is your beta pq equal to gamma p gamma q by gamma p plus q. Here in this class, whatever the questions we are going to discuss, the questions will be solved by using these two properties dominantly. Okay, consider LHS of the given question. It is given that beta pq, which will be equal to gamma p into gamma q by gamma p plus q. Let this is your equation number 1. This is a very simple question. Okay, now we are going to consider the RHS part of the question. Now consider RHS part. RHS, that implies in the RHS what we have, p plus q by q, this is q, okay, is equal to, sorry, into beta p q plus 1, which will be equal to p plus q by q, and by using relation between beta and gamma function, here this one can be written as gamma p into gamma q plus 1 by gamma p plus q plus 1. Okay, here you just write these things, we written this much by using the relation between beta and gamma function. Okay, which is the second property what we have been discussed in our last class, last class. So same thing, by using relation between beta and gamma function, this beta p q plus 1 written this much, right? Now that implies p plus q, that means your RHS, into beta p q plus 1 will be equal to how much? Here p plus q by q into gamma p तो है, ठीक है। देन हियर गामा, दिस वन गामा q plus 1 will be written as q into gamma q by using the first property of gamma function. No need to write this one, these things. By using first property, no need to write because we know that one. Okay, and this one gamma p plus q plus 1 can be written as p plus q into gamma p plus q by using first property of gamma function. You can check your note. So here you can see this p plus q, p plus q, q and q got cancelled, and we found the RHS. This is the RHS, no? Or we can write this. RHS will be equal to how much? Gamma p into gamma q by gamma p plus q. This is your equation number 2. Now, if I am going to compare equation number 1 and 2, then LHS equal to RHS by comparing equation 1 and 2, we get LHS is equal to RHS. Okay, hence proved. Okay, okay. Now we are going to go for our next question. Question number 8. The question number 8, it has been given that we have to prove beta p plus 1 q plus beta p q plus 1 will be equal to beta p q. Okay, from LHS we are going to solve it using the properties of beta function, that is your symmetry property and relation between beta and gamma function. So here proof starts. From LHS what we have? From LHS we have beta p plus 1 q plus beta p q plus 1. Okay, now is equal to, by using relation between beta and gamma function property, this one beta p plus 1 q can be written as gamma p plus 1 into gamma q whole divided by gamma p plus 1 plus q, or we can write p plus q plus 1. Okay, plus this one beta p q plus 1 will be written as gamma p into gamma q plus 1 by gamma p plus q plus 1, right? Okay, is equal to, here we are going to use the first property of gamma function, that is your gamma n plus 1 is your n gamma n. So here gamma p plus 1 can be written as p gamma p, gamma p, gamma p into gamma q तो है. Okay, here gamma p plus q plus 1 can be written as p plus q into gamma p plus q by using first property of gamma function, plus here gamma p है इसको लिख दो. Gamma q plus 1 can be written as q into gamma q. डिनोमिनेटर क्या हो जाएगा? वही p plus q into gamma p plus q. Okay, okay, is equal to, here you can see I'm going to add these two terms. The denominators of these two terms are same, so if I'm going to add, then it will be p plus q into gamma p plus q. You just add the numerators. Here gamma p and gamma q both are common, can be taken outside. Gamma p into gamma q, and we can get p plus q. Okay, p plus q. So here you can see p plus q got cancelled, and we found gamma p into gamma q by gamma p plus q is nothing but your beta p q. which is nothing but your RHS value. Hence proved. Okay, so from LHS we just by 1 2 3 steps we prove the RHS. Okay, okay, now we are going to move to our next question, question number 9. The question number 9 given that we have to show this one, beta s plus 1 t by s will be equal to beta st by s plus t equal to beta s t plus 1 by t. Okay, here you can see previously we considered always beta pq. Okay, but here beta st came. You should not be confused. I told many times that here this p and q are the dummy symbols, can be changed to any letter. So here in the question s and t are written instead of pq, so you should not be confused about that, because pq are the dummy symbols, can be written by any letter. Okay, now we are going to start to prove this question number 9. Proof. First we are going to consider this term beta s plus 1 t by s. This can be written as using beta and gamma relation s, सॉरी पहले हम ऐसे लिख देते हैं गामा s प्लस 1, उसके बाद लिखेंगे, ठीक है, गामा s प्लस 1 इंटू गामा t बाय s तो है, बाय गामा s प्लस t प्लस 1. ओके, is equal to, here we are going to use the first property of gamma function, that is your gamma n plus 1 is your n gamma n. Here gamma s plus 1 will be written as s gamma s into gamma t. Okay, divided by s into here gamma s plus t plus 1 can be written as s plus t gamma s plus t by using first property of gamma function. Here s got cancelled, s got cancelled. We found gamma s into gamma t, gamma s into gamma t by s plus t into gamma s plus t. So here this much, gamma s into gamma t by gamma s plus t is nothing but your beta st, beta st by s plus t. I think first one we have been proved here. This much equal to this much we proved. Okay, here we can write proof, proved, proved. Then we are going to consider the second one, this one beta s t plus 1 by t. Now consider, beta s t plus 1 t plus 1 by t. Okay, then this can be written as, by using beta and gamma function, gamma s into gamma t plus 1 by t तो है, ठीक है, then gamma s plus t plus 1. Now we are going to use first property of gamma function, gamma n plus 1 equal to n gamma n. Here gamma s है लिख दो, ठीक है, here gamma t plus n will be written as t gamma t by using first property of gamma function. T here gamma s plus t plus 1, again we are going to use the first property of gamma function. We can write s plus t into gamma s plus t. Here t got cancelled, and we found that here this one gamma t by gamma s plus t is nothing but your beta s plus t by s plus t. Here beta s plus t by s plus t, we proved this one. Okay, we proved. This is an important question. You just practice and remember for 4 mark question in your for your exam. Okay, now we are going to go for our next question, question number 10. The question number 10 given that we have to prove beta pq equal to p minus 1 factorial q minus 1 factorial whole divided by p plus q minus 1 factorial. Okay, so let us prove it. Okay, here you can see in question number 8 what we proved. In question number 8 we proved beta p plus 1 q plus beta p q plus 1 equal to beta pq. Okay, this expression I'm going to use to solve the question number 10. Okay, so previously or directly we can write, we know that here you just for your reference you just write from question 8. Okay, from question 8 what beta pq is equal to beta p plus 1 p plus 1 q plus beta p q plus 1. This much we know. By using this expression we are going to prove question number 10. How it is, here can see that implies beta pq will be equal to this one can be written as, by using relation between beta and gamma function, we can write gamma p plus 1 gamma q by gamma p plus q plus 1 plus this beta p q plus 1 can be written as gamma p into gamma q plus 1 by gamma p plus q plus 1. Okay, okay, we know from the properties of gamma function, gamma n plus 1 is equal to n gamma n or n factorial, right? Gamma n, likewise gamma n will be n minus 1 factorial. This much we know, we are familiar with this also. Now we are going to use this property in the above expression. That implies the above equation can be written as beta pq will be equal to, here gamma p plus 1 in factorial format will be written as p factorial into gamma q will be q minus 1 factorial by gamma p plus q plus 1 will be written as p plus q factorial. Likewise second term we are going to modify like here as like gamma p will be p minus 1 factorial, gamma q plus 1 will be q factorial, gamma p plus q plus 1 will be written as p plus q factorial. Okay, okay, that implies beta pq will be equal to, here p factorial can be written as p into p minus 1 factorial, right, right, into q minus 1 factorial है उसको लिख दो by p plus q factorial. Okay, plus here p minus 1 factorial है उसको लिख दो, q factorial can be written as q into q minus 1 factorial. Here I written p factorial as p into p minus 1 factorial, q factorial as q into q minus 1 factorial. How? Here you can see, suppose we have 5 factorial, this can be written as 5 into 4 into 3 into 2 into 1. Here 5 into this much is nothing but your 4 factorial. Okay, so if this is your n, so n into n minus 1 factorial, right? So only for that p factorial and q factorial are written as p into p minus, here p minus 1 factorial, q factorial, this one is written as q into q minus 1 factorial divided by p plus q factorial. So here you can see in these two terms the denominator is same, so you just add these two terms in the right hand side. What we can get, that implies beta pq will be equal to p into, here you can see p minus 1 factorial q minus 1 factorial, here p minus 1 factorial q minus 1 factorial are common, so I can take common from these two terms, p minus 1 factorial into q minus 1 factorial, then the numerator will be how much, p plus q, as the denominators are same, so we have to write p plus q factorial, simple addition. Okay, that implies beta pq will be p minus 1 factorial into q minus 1 factorial into p plus q by, here this one p plus q factorial can be written as p plus q into p plus q minus 1 factorial. So here p plus q got cancelled, and we found p minus 1 factorial into q minus 1 factorial divided by p plus q minus 1 factorial. I think we have been proved it here. Beta pq p minus 1 factorial q minus 1 factorial by, okay, yes, hence proved. Okay, so here we are going to stop our discussion of this class. In this class we discussed 4 questions which are based upon, or which are solved by using properties of beta function. Okay, in detail we have been solved. In our next class we are going to discuss few miscellaneous questions belongs to gamma function and beta function. Okay, so thank you so much for watching this video. Thank you.